Hello, my name's Matt Robinson. This is my honors project, and I will be showing you temperature versus bounce height. So, I'm a competitive tennis player, and I've always been interested in why tennis balls bounce differently in different conditions. My experiment idea was to test rubber, tennis, and ping pong balls at 3 different temperatures and then measure their respective bounce heights. My hypothesis was that if each ball was exposed to 3 different temperatures, then the rubber ball would bounce the highest out of the three because of elasticity. The tennis and ping pong balls would then follow in that order. My initial research included getting a better understanding of the concepts of elasticity and potential energy. Elasticity comes from Newton's third law, where every action has an equal and opposite reaction. This is the ball's ability to compress once it hits the ground and quickly regain shape in order to bounce up again. A rubber ball is obviously made from rubber, whereas a tennis ball has a rubber core but is covered with felt. A ping pong ball is made of celluloid, which is similar to a plastic, but is not a true plastic. Potential energy is the energy of an object based on its position, and it has the formula of potential energy equals mass times gravity times height. Tennis ball has more mass than the other balls, and also more potential energy as well. The materials for the experiment were pretty simple. They included 3 of each type of ball: measuring tape, a wall, scale, refrigerator, heating pad, and video camera in order to see the true measurement. The procedure included placing the tennis ball in a refrigerator for 30 minutes, then the heating pad, and then leaving the third tennis ball at room temperature. Then each ball would be dropped from 48 inches, one at a time, and a video would be taken for an exact measurement. I would then record each bounce height in the table and then repeat steps 1 through 6 with the rubber and ping pong balls. The results were pretty interesting for the experiment, where the rubber ball bounced significantly higher than the other types of balls. I was right in my hypothesis that the rubber ball bounced the highest out of the 3, followed by the tennis and ping pong balls. However, I did not expect that in the experiment, the ping pong ball's bounce height would stay the same despite any temperature changes. This is because celluloid is a harder material and is not elastic or bouncy the way that the tennis and rubber balls are. In terms of possible errors, there could have been some temperature change when the ball was taken out of either the heating pad or the refrigerator, which could have resulted in off measurements. There also could have been human error in measuring and balance and ball drop. Also, the tennis balls were slightly worn, which could have affected their bounce height. Some improvements to the experiment could have been from changing ball drop from the wall to a higher table for a more consistent drop height. I could have also used 3 new tennis balls. Some extensions to the experiment include dropping the balls at different heights and using different sizes of rubber balls to see if there would be a different result.